Hello, Form 2 student, here Mr. Zheng. So we are keep going to talk about the question in chapter 7.5, application of simultaneous equation in two unknown. So now I choose a question about speed. Okay, so you can find it on page 7.40. Okay, so this is a question in consolidation task. Okay, consolidation task, question 3. Okay, so we say that there is a boat sails along a river between two cities A and B. Okay, and the distance for a single trip, whatever upstream or downstream, is 6 kilometers. And the boat takes 30 minutes for sailing down the river from A to B, and 45 minutes for sailing up the river from B to A. Okay, so let's write a simple diagram to try to understand this question. So let's say there is a river. So here's a river. So I draw some water flowing. And here are two cities. One is A and one is B. So question say that the single trip, that means the distance between them is 6 kilometers. Alright? And then it say that the boat takes 30 minutes for sailing down from A to B. That means it sails from A to B for 30 minutes. And then it sails from B to A, so in different direction. It used 45 minutes to sail. Okay, and then it say that A to B is sailing down. And B to A is sailing up. Okay, so try to consider the diagram from the question. Alright? Wow. Okay, see it? Okay, so the two cities A to B. Okay, single trip 6 kilometers. And then from A to B 30 minutes. From B to A 45 minutes. Okay, so 45 minutes is sailing up. 30 minutes is sailing down. Okay, so this is the description of the diagram. Okay, now on the other hand, for question A, it say that let x kilometer per hour be the speed of the boat when it's sail in still water. So still water means the water doesn't flow. And y kilometer per hour be the speed that the boat gains when sailing down the river due to the water current. Okay, so gain means the speed of the boat is increased, okay, by pulling from the water. Okay, and that speed is y kilometer per hour. Alright, so express the speed in kilometer per hour of the boat in terms of x and y. Okay, so we try to add these two speed into the diagram. Okay, so from A to B, the boat is sail to this direction, right, by x kilometer per hour. On the other hand, from B to A, it sail in another direction. The speed is also x kilometer per hour. Okay, because it's assumed it is sails in still water. However, the water is flowing. Okay, and the current is flow with y kilometer per hour. Okay, so if the boat is sail to the same direction of the water flow, the speed will be increased, so the time used will less than the other way. On the other hand, if it is sail against the water flow, okay, the water flow in this way, but the boat sail in this way, so it will be slower, so the time used will be more. Okay, so let's go to question A. You need to express the two speed, okay, by using x and y. So if it is sail up the river, that means in this example, so the speed of the boat, okay, here you take a look, the speed of the boat, okay, will becomes x but force by the water flow. We just need to directly subtract the speed, x minus y. Okay. On the other hand, if it is sail to the same direction of the water, the speed will be increased by y. Okay. So, and then B, we try to solve the equation, right? Okay, so in this part, we know that okay. So we have many ways to solve this equation, because maybe we can use the definition of speed first, right? So for the first part, okay, speed of sailing, maybe speed of sailing down. Okay, we try to use the number, okay, the numerical number to represent it, because it say that when it is sailing down the river, for the 6 kilometer at distance, it used 30 minutes to travel, right? Okay, so maybe first of all we may try to convert the unit. Okay, so let's say we try to convert 30 minutes to hours, because we need kilometer per hour, so this is kilometer, this is not hour. Okay, so we change that to hour. So 30 minutes, change it to hour, we should divide by 60, so it is 1/2. For 45 minutes, we also try to convert it to hour, also divide by 60, so it is 3/4. Okay, so back to here, the speed of the boat sailing down, that should be 6 divided by 1/2. Okay, because it is distance over time, that is speed, right? Distance over time. So we find that it is 12. Okay, so on the other hand, when the speed of boats sailing up, it should be the same distance but different time used. Okay, is it okay? So we find that the speed of the boat can be found by two ways. The first is x and y representing the speed of the boat and the water current. It is provided by the question. And you know that the x and y can be represented by using x and x in terms of xy is x minus y and x plus y. This is the speed of the boat in sailing up and sailing down. On the other hand, the value is given. Distance is 6 kilometers, and the time for the boat use is 30 minutes and 45 minutes. Okay, and we know that the speed is always equal to distance over time. Okay, so we learned it from our primary school, right? Speed is equal to distance over time. So we try to use the distance over time. Okay, but the time is not in hour because we want kilometer per hour. So we convert minutes to hour. Alright? So back to the question. A, given to you the speed. B, we find by the value, the numerical value, the speed of the boat. Both of them are the speed of the boat. So that means actually they are the same. Okay, so sailing up is 8. Alright? So you set a set of the equation. And then we try to solve that. So this time I try to add them up because their coefficient, the x and the coefficient of x and y are both 1 only. Alright? And then actually x represent the speed of the boat, and the question only asks you for the speed of the boat, so actually you can stop your calculation here because I've already found the answer. Okay, so this is how to solve this question from a diagram to the whole question. And actually this question is not easy to understand because you can see that for the first part of the sentence it doesn't mention any value that you should find. It doesn't mention, just give you some information. So for the first 3 sentences you can only draw out a diagram. Okay, understand the city A, B, and understand the boats, the direction of the boats, and also the time used. And then you can set up some relation from the question A, because it's given to you the unknown x and y and what does that they mean. Okay, and then you try to combine them by the flow of the water, the direction of the flow of the water, and then you give the 2 expression of sailing up the river and sailing down of the river of the speed of the boat. Okay, so we find that they are x minus y and x plus y. And then for part B, we go back to the first 3 sentences to take out the value we need, the 6 kilometers, the 30 minutes, the 45 minutes, to find out another representation of the speed of the boat. Okay, so we convert the unit and then write out the speed of the boat, and then we easily combining the answer from A and what we find from B to get 2 equations. And then the procedure to solve the equation is actually very easy. And then we find the answer x. That is the speed of the boat in still water. Okay, so that's the end of this question. And now maybe it's your turn to try the same type of question. So you may find one question about speed in your exercise. Is you can find the question 30. Okay, question 30. Okay, it's about the speed of bicycle and running. Alright, so maybe show you the answer. X equal to 30 and y equal to 6. Okay, so that's the end of this video. So maybe this is the last video to explain the different type of question in this chapter. Okay, actually there has many other type of question. Okay, it's quite difficult to talk about any question. Okay, all the question. But if you find that any question is difficult for you or you don't have any idea to solve it, you may try to ask. Okay, so that's the end of the video. See you.